As I've been kind of working on the scanning probe microscope rig that I've been trying to put together lately, I thought I'd do a quick video on just the latest changes as a kind of log of what's happening and how things are going. So the big thing that's happened is that this thing has arrived, which is the custom designed enclosure and mechanical system that I had machined out of aluminium. I got that done by Star Prototypes, and it was a little bit expensive. I'm looking at kind of cheaper options, but it was about 300 quid for the what was it? 1, 2, 3, 4 parts that kind of make up this actual enclosure. So that's arrived, so I should be good to go when I have the electronics properly working. I recently did another video on the DAC boards and the issues that I've had with those. So I've got some parts coming tomorrow, so hopefully those will be up and running soon. But I thought, just as a log, it would be a good idea for me to do a video, partly just so I remember what this stage kind of looks like. Basically what we have is we have a pico motor for the coarse approach. This gives 30 nanometer resolution over 25 millimeters in the Z axis. So with a probe microscope, you've basically got a substrate, and then the probe approaches the substrate and then it scans across it. But the probe should never touch, so you have to move it with quite high precision. So you need a coarse grain actuator to just get the substrate nearish the probe, and then you have a fine grained actuator that gets it within within nanometers of the surface. And in this system, I've put all of the motion on the substrate, the thing that we're looking at. So the probe stays still and the substrate moves around, it kind of goes closer. It moves around. So this is the coarse Z to just get it near to the probe, is this pico motor. Then for the fine Z, there's actually just like a buzzer. It's a piezo buzzer is in there. I'm thinking of changing that, but obviously people have had success using piezo buzzers for fine-grained Z control on these systems. So that's what, in the first instance, I'm going to try. That sits on top of an XY piezo stage, which is this thing. I've done other videos on this, but it is just a XY stage that I bought off eBay, which is supposed to have about 15 microns of travel, and I believe has nanometer to sub-nanometer resolution, but a lot of that will depend on how you're driving it. So that's the mechanical system and the actuation. And the way I've designed it is like the probe is fixed, and it sits in this, if I can just remove it. So this is the mechanical system for the probe, the fixture. So this is obviously for STM operation, and I'm thinking of designing different probes to sit in there. But basically this is Teflon tubing, and then the platinum iridium wire sits inside this Teflon tubing and is clamped in place by this little clamp setup here. So that clamps it in place, and then it just slides down. And if I bring the camera a little bit closer, you can see. So it just kind of screws. Yeah, so it screws in place here. And I have actually screws here, so I could use grub screws as well to kind of put it in place, keep it in place if I wanted to. But I'm hoping that'll be quite stable anyway, I think. So yeah, with the platinum iridium wire, what the plan would be is to pull this through and then do the cutting process, and then to pull it back and clamp it in. So you actually cut it while it's in the fixture. That's the idea. In the rest of the system, I designed it to just run off, to be largely basically a DC input system. So these two SLA batteries which provide a split input. It's a 5-volt regulator which is required for the picomotor. That requires plus minus 12 and 5 volts basically. So that's the drive for the picomotor driver, which is, and I have a blog post on this, it's a New Focus 8701 driver. And it just takes a direction and a pulse, much like stepper motor drivers do. Yeah, so the output of this goes into this board with a 5-volt regulator, and then it heads out into the picomotor driver. That also fields a 5-volt reference board, which then goes into this ugly mess of wires and provides 5-volt reference for the DACs, and this also provides the plus minus 12 volts for the DACs, all coming off these ribbon cables. I don't particularly like that, and I can see that being a source of noise and a problem, but I basically want to see if I can get the system up and running. The mechanical system, the shield, obviously, the shield is system, is one ground in this system, and then the probe is another. There's a bias voltage across that, which is provided by this battery, and feeds in that the current sensing the current that travels across that gap is obviously tunneling current if this is running as an STM, and that is sensed by this transimpedance amplifier, which then feeds into an analog to digital converter, which is also on the Arduino, and that goes off to a PC. That acquires images. The Arduino controls all the scanning and acquires images. Potentially, it would be nice to run it as a fully shielded system at some point, so that the whole image acquisition could occur on the Arduino, and it could all be just inside a Faraday cage and captured, and then taken out, plugged in later for further processing, which would give me really good shielding, which might be quite kind of interesting and fun. But there we go. That was just a quick log of the system, how it looks at the moment. Yeah, I don't think there's anything else to say.